let me first start with saying that due to the conditioning here, my voice is a little bit down. But no matter, I will try to manage, right? So in this talk, I will talk about speed, or web application performance. So at first, a little bit about me. Beforehand, everything worked beautifully. Okay, so hi, once more. I'm Linas Linartas, but if you have trouble saying my name, you can just call me Lily. I won't mind. I have been working in web application development for around 10 years, for more than a decade. And during this time, I worked in various business domains, whether it be e-commerce, travel, last-mile logistics, and even telcos. And during all those years, and in all those business domains, one topic always came up, the topic of performance. So, most of you, I think, already know why speed is important. We like speed. We watch Formula 1 for the fast cars that go vroom, 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 vroom. Children also watch Lightning McQueen to go vroom, 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 vroom. This is just natural for us. We like speed. And in the same way, we like web applications that are fast. Why? But to go a bit deeper down, why is it important? Well, first, it can lead to customer retention. And customer retention is good. It shows more ad views. It can lead to direct sales. And in short, it can bring you more money. On the other side, performance can affect operational cost. Just as a simple example, AWS Lambda, the serverless compute function, is charged by the duration. And there's a huge difference between a function that takes a minute and just a few subseconds. Finally, for some operations, performance can be critical. Let's say you have a daily sync in an e-commerce way where you sync data like prices or stock movements. And well, if that sync takes 60 hours, I can tell you that you will have a very bad time. But I think you all knew this. However, I want to share a little bit of a secret with you that you didn't know. The title of my presentation is actually not full. Yeah, speed is king, right? That's quite normal. And slowness is not such a nice word at all. So, I think we need to speak about speed and the other side of it. Because, in my opinion, any sufficiently complex application will inevitably have performance issues. And to solve those issues, it is quite difficult to do. There are a lot of struggles. First, performance issues affect the whole application, like all the aspects. For example, backend, frontend, database, network, anything you can imagine. And to truly solve those issues, you need to see the bigger picture, always. Otherwise, even when you try to solve and see the bigger picture, it's quite hard to estimate or calculate the cost of those issues, right? Because the problems are more vague. This is not just add another button with a red color. And finally, even when you did the estimation, you did a difficult analysis part, some solutions, sadly, do not bring sufficient results. And that's a problem. And during those years, we just try to, from our experience, find some method, just a framework, on how to solve those types of issues. And from here, let's talk a bit about the iceberg. So, why an iceberg? Well, it's really hot here, at least for me in Lithuania, where I live. It's now minus 15 degrees and snowing. So here it's a little bit of a better one. Also, I really like YouTube. And on a long 9-hour flight, you can really just relax, sit back, and hear some kind of crazy conspiracy theories that are presented in an iceberg format. And there's one more simple thing. Imagine your performance problems as a big iceberg in the ocean, right? And you have a ship, and you're driving, flowing through the currents. And if you ignore that iceberg, you will end up like a very famous ship. Okay, so what is this model? And believe me, it's dead simple. The essence of how to tackle these types of problems when you are facing them is first, just analyze, identify the performance problems. And I want to emphasize that what you need to do is to evaluate everything, all the aspects of the application. And this means backend, frontend, network, anything that composes your whole architecture of the web application. Right? And every application is unique. So every time this needs to be done anew. Then going forward, think of the solutions and try to apply them. But again, one very important thing. Start from the most easy solutions and proceed to difficult solutions only if needed. And in this process, always iterate. So you did your changes, you reanalyze your application. Oh, it's still not good. Then you apply more difficult solutions, and you go in this type of cycle, in this really agile way on how to tackle performance issues. And why? Then, why do we do this? What is the mindset when working in this type of way? Well, it is related to two very simple principles, right? And connected ones, the law of diminishing returns and the principle of good enough. So it's also in other topics called like Pareto principle or the 80-20 principle, but in essence, it's better to do something well than to do something perfect, because the amount of efforts to do something perfect might be way out of hand. So maybe you just need to spend a few man-days of work to get good enough performance, rather to spend months and months and months of work to get that perfect performance. As a simple example, if you have that situation where the daily sync takes around 60 hours, maybe you just need to make that 20 hours, right? And it will be good enough for then. And if that sync is done in an hour, maybe there's not such a big business impact for the process, as an example. So you just need to find something that is good enough for your application and try to strive to that. And this applies to synchronization tasks. It can apply to even page openings and so on. So yeah. So for the later parts, I would like to just once more go through the iceberg and see how we can visualize it. And we are trying to visualize it so that we can remember this, right? Because what knowledge is, if I say something and you just forget, this talk will be not as good. But if you try to visualize it, see the ocean currents, try to feel the coldness of the ice, it will be better. So first, we have the iceberg. And you see, we have peaks. And an iceberg is created from various icy peaks. And these peaks we call pillars, and they represent the different aspects of your application. In this case, in this presentation, I just tried to create like 4 different ones: front-end, network, backend, and infrastructure. But in your case, it can be different. Maybe the database itself or the data storage options should be just a separate one. It's not a big difference. So we can splice the iceberg vertically and see those pillars. And if we splice it horizontally, we can see the difficulty of the solution. So we have easy solutions, the more complicated ones, and the nightmare solutions. And yes, the nightmare solutions are those terrible ones where you go to your product owner and said, you know, we need to rewrite the application in Rust, and so on. It might not be a nightmare to the developer. He might be very, very motivated to do that. However, for business, in many cases, these types of situations are a nightmare. Okay. So, as I mentioned, quite easy, right? Now, let's start and just take a Ghana at the first part on the analysis and identification of problems for your application. And the most important thing I want you to take away from this talk in this section is to just use professional tooling and do not try to reinvent the wheel. Do not try to profile your code manually from start to finish, because that is just not effective. Because performance monitoring tools are a force multiplier. They can help you do the analysis work many times faster. And of course, sometimes that is not what business believe, because they see the costs, right, and they do not want, and I will help with that. So some takeaways from the analysis part. Use tooling. For front-end, it's that simple. Any browser already has it. Just open your web dev tools, open Google Lighthouse, generate a report, and that will be good enough for now. For backend solutions, it's more complicated, but again, try to use professional profilers. And as I am working mainly in PHP, so these are all good options like Blackfire, Tideways, or New Relic. Disclaimer, I do not really, I do not care which one you would use, or I have used all of them, and that's just it. And of course, if all else fails, you just need to profile your code and see the data, because performance monitoring and this analysis of issues should be a data-driven endeavor. And again, now, especially during these few years, those professional profilers, well, VC money evaporated, and they really increased their costs. And for some businesses, even small businesses, that might seem quite a bit. But we can always, in these situations, use a very simple math. So you just take a developer's hourly rate in monies and compare it to the tool that is many times charged by the month, right? And that's a very simple break-even. You can calculate. And if that tool has been able to fix your problems and so on, in just a few hours, you got the return on investment. And in my opinion, personal experience, we have been able to find, analyze and find those issues in record times compared to very complicated situations. I'll give you a simple example. We had a truly problematic case in one of our websites for a client, and the client initially was really against spending more money. You know, you already want some logging tools, and then you need other tools. Why I'm paying for all of this, right? Analyze yourselves. Well, the team spent a week, 2 weeks, and they found some issues, they found some problems, right, fix them, but the site was still slow. And only when the clients, developers, everyone was fed up, they decided to invest in it. So we install one of the profilers in the code. Oh, and we found it from the first report that we generated from the homepage. We already found huge issues in the vendor code, right? The problem, the true actual problem, was not even in the application code, because we do not make bugs. But it was actually, in this case, in the vendor code, and nobody from the development team really thought even to look there, because we have those assumptions and we have biases. And these types of things really make it hard sometimes to find those issues. So, okay. Now, I just want to go through all of the pillars from the different aspects and just tell you from my experience what is the most important things. So just you can imagine this talk can be originally like an hour or more. And I just cut a lot of content from here, so to get you the essence, the gist, the main things we need to take into account, or are the lowest hanging fruit that can help us, okay? So let's first start from the front-end pillar. When you open any web application, you see the document, you see the nice Jumbotron pictures and so on. And well, the first part where you can do some analysis is just to take a look at those pictures. Because I can tell you that for most simple cases, you just open a website and you are bombarded with huge, high-definition images, like 4K max resolution, which is completely unnecessary. And actually, it can even more decrease performance, because then your computer needs to compress that huge 4K or even 8K. We had a situation with an 8K image that was compressed into a thumbnail. And even that was the biggest impact for the whole front-end part. And yeah, you can just manually or automatically resize those images. For some more complicated situations, you can use content delivery networks, which really help, especially if that server and the customer or the client is quite far away from each other. Then you can use other guidelines that even Google recommends, like using next-gen formats. You can create specific also versions of the assets. So you have a big picture, a medium-sized picture, for example, the product detail page, and then you have a thumbnail, all separated so that both the server decreases its load, and also you always show the most efficient image to the user based on, for example, his screen size. And one of the other parts that you might use is to lazy load images. So lazy loading is a bit more smarter way that is especially important for pages like product catalog pages, right? In e-commerce, you open, you see, let's say, 50 cards, and if you need to load every single image, it will take some time. But okay, not everything is related to images, assets, and so on. There might be other parts of the application, and of course, I will just show you some minor things. So still, let's use best practices from the front end. And first, if you have style sheets and scripts, first minify and concatenate them. So just create a single file. And for more complicated use cases, for big projects, I recommend to create bundles. So newer front-end tooling like Webpack and so other ones you can create specific bundles. One for the shared scripts that affect all the application. You can create a bundle for the admin section and so on. And I just want to mention here that for front end, there's an interesting thing that sometimes, and I mean sometimes, performance is not as important as the appearance of the appearance of performance might be more important. So that means when you're doing some show loaders, show fake images, that are just placeholders before you load the actual image and so on, and the customer appreciation, the user experience will increase. Okay, but front-end is not my forte. I'm more of a back-end guy. However, between backend and frontend, there's always one very important thing that is oftenly overlooked. It's the network. And your backend and your frontend needs to talk. And many times they, of course, talk through HTTP. However, every HTTP request costs you performance. One my stories of the biggest fails that I have seen, let's say, and biggest savings was regarding this network pillar. So just an example from the top of my head. We once had a Spriker system, and rogue PR that was easily accepted, did not through look, did a change that every translation call would do an HTTP request. So that means when you go to the homepage of the site, you are doing 200 HTTP requests to the backend? That was not very well. Also, apart from that, also the HTTP request and response diagrams are incredibly important in microservice architectures, because sometimes you think of, creating your services spread out into the different domains. However, businesses, when require some kind of data, you need to aggregate from different sources, and the amount of HTTP calls can exponentially rise. So we had a situation when we fetch, let's say, 10 documents, and for every single document that also fetched other 10 documents, and for a single, call that the front-end things, you do hundreds of microservice HTTP calls. Bad time, don't recommend that. Also, for more adventurous of you, or just using more new infrastructures, I want to mention that newer standards of HTTP, like HTTP 2 and 3, they bring performance improvements. And finally, just talking about different network stacks, be wary of different cloud setups. We had quite a few problems when working between AWS Cloud and Microsoft Azure, because it costs huge amounts of money, and the performance is quite slow. And if you are creating a single architecture for your web application, I truly recommend to keep it in one cloud at least, or optimize it further. Okay, then let's go to my love, backend. And for backend, it's actually not even the PHP code that you first need to look. In many cases, the database is the biggest bottleneck. And the first thing you just need to do when faced with a problem in the backend, check your database indexes, which improve dramatically the read times of the performance. Right? An interesting story. MySQL, right? No, you know what is MySQL, the database. When you create a foreign key, you create two different connections, like order and order item. You create a foreign key. So MySQL creates a database index silently. So the fetch, if you want to get the order with the order items, it's fast by default. However, if you're using Postgres, which is much more theoretical in nature, those are two different aspects. And just if you create only foreign keys in Postgres, at least in some previous versions, an index was not created automatically. And we had a case where a client that was, really hungry and really desperate, they asked us at NFQ to do an audit, and he said nearly money is not a problem, just please fix it, because customers are happy, the investors are angry, and so on. So our colleagues went to the database and just added in a single day all the indexes for all the foreign keys, and would you know what? The problems were fixed immediately. No high engineering, we needed to do that. Of course, with databases, we can use more complicated aspects also, like database sharding or read-write replica creation. And they are useful, however, they are more complicated. And now I'm just going to the low-hanging fruit, as we call it. Also, when we are talking about databases, backend performance, one thing should always come in mind. Hey, what can we cache? Caching is one of the best ways to just improve the performance. And when you're working in a sufficiently complicated application, caching is much more like an onion. So you need to cache in the different layers of your application. So at the topmost, you can cache your HTTP responses for some period of time or something. You can create memoization or just processing, a simple example how much Fibonacci number sequencing can be improved. The generation of Fibonacci numbers can be improved just by memoizing the intermediate results. And you can do that in even business situations. And finally, you can just cache what data you get from the database or the queries and everything around that. Okay, another part regarding data storage is using specific storage options, specific engines for specific tasks. So in this case, for simple caching issues, you can use Redis that stores data in memory, and this can easily, and this, I mean truly, truly bring enormous impacts for your application if you just use the right tool for the right job. Oh, and for more truly backend tasks, for specific situations, you can move synchronous processes to asynchronous processing. So when we are talking about AWS SQS or RabbitMQ processing, that is always a good option to explore. Of course, it will take some more time. It's a more complicated, but truly brings benefits. And I just know that people are always like to talk about this, so I will not explore now. And finally, the thing that in my experience is many times overlooked actually, the physical hardware. When I mentioned that we need to look at everything, we need to look at everything. And in some situations, maybe not on productive systems, but at least for staging or others, your local laptop that you work on might be faster and more powerful than the hardware that is in the cloud due to costs, budgeting, and so on. And you know, as a general rule, production environment should be much more powerful than your local environment. Simple, right? Also, don't forget about your storage compared to physical, like hard drives and SSDs. I have a funny story to share. We had a big business critical application for a last mile logistics provider, right? And the reporting was incredibly hard for the server. Like we could have run it only at night when off hours, and we decided that enough is enough. For even new reports, we needed to introduce a read-write replica, so the reports would be generated from the replica. However, that replica was on HDDs, right? You know, slow hard drives, and all that effort for the replica was completely out of the window for NAND, and we needed to change that. Yeah, and finally, just a simple thing that is more, of course, of a DevOps or SysOps operations. Don't forget, check your configuration. Check your page sizes, your op cache settings, for example, in PHP. Also check your database configurations and so on. If you actually use some of those tools, I recommend it for the profession. They give you tips and pointers on where some misconfiguration might have happened. So yeah. That's it. This is the conclusion, and it's quite simple. Performance is important, and performance problems are complex. And always analyze your application, use tooling if you can, analyze all the different aspects of your application, and just start applying solutions from the easier ones to more difficult ones, so that you can achieve this efficiency. Because the idea of this talk is to show how at least I like to work. I do not like to imagine myself in, you know, a cosmic programmatic place where nothing matters. In my opinion, as a software architect, we really need to take into account the context. So how much money do our solutions cost, whether I am working in the most efficient manner as possible. So, and with this, I hope you will too. Any questions?
Any question, everyone? Can I see your hand? Okay. Anis.
Okay, so I have a question regarding to the front end. You say like we need to check the networking, a lot of different things, but sometimes we work on a components that we don't know. Like I would say, let's suppose we are working on a tree component, and we don't know how many nth child that have, and it generates on the real time, and we cannot cache the data, we cannot optimize it using the images and stuff. So how would you suggest we can do that?
So, what you said that I can rephrase it, right? As whether I understood you fully. So, when working, I guess, especially on SPA, like with React or Vue.js, you work on the components, but you do not fully control, right, the child components in that application. And it can really be difficult to analyze those things because maybe those components do re-rendering on every talk, and it's just not optimized. So sadly, there is no silver bullet in this case, and you just need to, again, think not about your single component, but that full stack, right? You need to see the full chain of command and see the bigger picture. And maybe you can create some kind of like optimization for that, or you just need to rework it. And it's every case by case, it's a unique one. So, you know, I will not give you silver bullet, sadly. Maybe I will, but later, okay?
Thank you. All right. Do we have any more question for Lily? All right. So I guess we don't have any more questions. So thank you so much for your talk. And as we have a little gift for you. Thank you.
Great. Thank you. I like gifts.
Thank you.
Thank you.
All right, everyone. So we have 10 minutes breaks for you to switch in room or like grab a drink. So I will see you in